variables. So what is a variable? Well, if you want your computer programs to perform useful actions, they need to store data that can later be processed. I have already explained that when you run a program, the operating system loads the program's instructions into memory, so while running, your program stores values in the RAM memory by using variables. The most simple real-world example is when you use a program to print a document. Among other actions, you need to specify the file that you want to print, the number of pages, etc. When you input these informations, they are stored inside memory locations in the RAM memory. Because the program needs to be able to later on find these locations, every location has a unique address. Because in modern computers there can be billions of such addresses, keeping track of every single one of them would be impossible. For this purpose, programmers invented the concept of variables, which are nothing more than a name associated with one or more memory locations. As the name variable suggests, the values that the program stores in these locations can be modified during the execution. As we will learn today, the most important characteristic of a variable is its type, which defines how much memory it needs and what actions can be performed upon it. Practically, when we want to define a new variable, we need to specify its type and a name followed by a semicolon character that ends the instruction. The process of defining a new variable is called declaration. The process of giving a value to a declared variable is called assignment. When we assign an initial value to the variable, we do what is called an initialization. In short, we can declare a variable and assign a value to it, thus initializing it. There are a lot of variable types, but as a beginner, you don't have to trouble yourself with all of them. There are 8 most common types of variables that you will use in most of your programs: int, byte, float, double, decimal, string, char, and bool. Let's declare a variable of type int. As I already said, this is done by specifying the type, in this case int, which is a shortcut for integer, followed by its name and a semicolon character. However, right now our variable has only the default value 0 because we haven't assigned any value to it. This is where initialization comes in. By using the assignment operator, which is the equal character, and specifying a number, we have assigned a numeric value to this variable. It is possible to merge the declaration and the assignment together in a single statement. The compiler even allows us to declare more than a single variable at once, and they will all be of the type we specified. Finally, we can even declare and initialize multiple variables in a single statement, but this is not something that you will see very often. By convention, variable names follow standards that are not mandatory, but it is considered good practice to follow. You can name your variables whatever you want, however, most programmers use what is called camel casing. The first letter of the variable starts with a lowercase character, and if the name contains more than a single word, the following words are each joined starting with a capital letter, like this. In the description, I will leave a link to a more detailed explanation about variables naming conventions for those that are interested. It is a good time right now to start learning about the binary system. As I was explaining in a previous video, computers only understand and work with 2 values, 0 and 1. These values are the smallest individual pieces of information inside a computer, and they are called bits. A bit can only contain a single value at a time, either a 0 or a 1. A group of 8 bits is called a byte, and sometimes a word. Byte is the smallest piece of memory that a computer program can directly manipulate. It is also equal to a single character or letter. So when we type the letter A, we now know that it requires 1 byte or 8 bits to be stored inside a memory. Binary counting is the same as the normal counting you were taught in school, with a single difference. The counting system we are all accustomed to is called base 10 counting because we count 10 values from 0 to 9. So we can say that it's the decimal system. We start from 0 and the upper limit is 9, after which we need to add a new unit on a higher magnitude. Similarly, in the binary system, we start counting from 0 and the upper limit is 1, after which we also need to add a new unit on a higher magnitude. Binary counting is really the same as decimal counting, with the only difference of using only the first two numbers from it. So, let's start counting in both binary and decimal system for comparison. In both systems, we start with 0. The next number is in both systems 1. Here, the similarities end. In the decimal system, the number after 1 is 2. However, since there is no value 2 in binary because the system ends at 1, we can consider that reaching 1 in binary, the last unitary number in binary, is the same as reaching 9 in decimal, the last unitary number in decimal. When we add 9 in decimal, we add a unit on the next higher magnitude and start counting the units from 0 again. In other words, in decimal after 9 we have 10, a unit on the next higher magnitude, tens, and starting again from 0 on the unitary digit. In binary, it is the same. When we reach 1, which is the last unitary number, we add 1 on the next higher magnitude and start again from 0 on the unitary place. Then we continue counting as usual. In decimal, the next number after 2 is 3. In binary, after 0 we have 1. Next, in decimal, it's simple. After 3, it comes 4. In binary, because on the units place we reach 1, we need to start from 0 again and add a unit on the next higher magnitude. But since we already have 1 on that place too, and since there is no 2 in binary, we add a unit on the next higher magnitude, the hundredths correspondent in decimal. And we also reset the tens equivalent to 0. Then in decimal we know 5 follows, while in binary we start counting the units again. Again in decimal, next is 6. In binary we reach again the point where units are 1, the last possible digits, so we need to reset them to 0 and add a unit on the next higher magnitude. And we can continue like this. Now again, in the decimal system after 7, we know that 8 follows. In binary, we reach the point where all 3 digits are the last number, 1, as in decimal 999, when all 3 digits are at the same last possible number, 9, and we need to reset them all to 0 and add a unit on 1000 place. It is the same in binary, and it goes like this forever based on the same principles I described above. It is not mandatory to learn to count in binary. However, doing so might help you better understand some finer aspects of certain inner works of programming. One last thing that I should explain before getting into details about variables is the interaction with the console. Just as with the binary counting, this lesson is not mandatory, at least not yet, because it is based on concepts you haven't learned yet. Anyway, it is required to understand, at least at a very basic level, the way we interact with the console. The console is the working area of a program that does not contain a graphical user interface, meaning it doesn't contain buttons, images, text fields, and so on. You have already seen it. It looks just like a black window on which we can display text. With console programs, the only action that we can perform are grouped into categories: input and output. Input is related to sending information to the program using a keyboard. Output is the reverse process of sending information from the program to the user by displaying text on the screen. There are multiple ways of performing input operations, but we are only interested in 2 for the moment. Console read and console read line are both codes for reading input from the user. The difference between them is that console read will read only a single character, a single letter followed by pressing the enter key, while console read line will read all the letters that we typed until we pressed enter. Like in the case of input, we are only interested in 2 codes that perform output actions. The only difference between console write and console write line is the fact that the first will display the text on the same line, while the latter will add a new line at the end. As you can see, we use write and write line by giving them some text arguments that we want them to print on the screen. This text must be placed between double quotation marks, and the reason for it will be explained when we learn about the string variable type. For now, we found out how to display text on the screen. However, what if you want to display the value of some variables? What if you want to display text and the value of some variables? Let's take an example. So, we declare three variables containing some numeric values such as age, weight, or height. When we try to display them on the console, all we need to do was to use the plus sign in order to add or join them to the additional text that we wanted to display. This method of using the plus sign to merge one or more texts or variables together in order to display them to the console is called concatenation. You can notice that we delimited the text that we wanted to display in front, at the end, or between the variables by using quotation marks. It is often challenging for beginners to comprehend the concept of using quotation marks or to grasp which starting quotation mark belongs to what ending quotation mark, especially in multiple segments concatenation, like in my example, but in time it will get easier. On the other hand, there is another way of displaying variable values mixed with some other custom text like we displayed in the last example, which may seem more complicated at first, but it's not. On the contrary, it is. And no, my age is not 0, my weight is not 1 kilogram, and my height is definitely not 2 centimeters. Actually, these are called parameters, and as you can see, they are included inside the text we displayed, as they are between the starting and the ending quotation mark. However, the compiler is smart enough not to display them as they are, as curly brackets with some numbers in between. Instead, it knows that for every such parameter, there is some value that we specify at the end of the text separated by comma. For each parameter specified in the text, we must specify such a parameter at the end or we will get an error. Please note that the parameters we specify inside the text start with 0 and not 1. In our example, we want to display three variable values, age, weight, and height. Therefore, we specify three parameters inside the text, numbers 0, 1, and 2. At the same time, I said that for each parameter specified inside the text, we need to provide another parameter at the end of the text separated by comma. Therefore, we added age, weight, and height at the end, and these are actually the variables we declared in the lines above. When we execute our program, the compiler knows that it must replace each parameter between curly brackets with the parameters at the end of the text in the order they appear separated by comma. More specifically, if you place 0 after the text my age is, and we also specified variable age as the first parameter at the end of the text, it will replace the value of this variable for the 0 piece, weight for the 1, and height for the 2 piece. If we were to put the variables in a different order, they would have still be displayed in consecutive order, starting from first. To conclude this lesson, for those that want to play a bit more with the console and want to customize the way they display stuff on the screen, there are some interesting ways of accomplishing this. For instance, we can set a background and foreground color for the text we want to display and many other things. Since in these lessons we learned what variables are and how we declare and use them, in the next lesson we will start to analyze the different types of variables and see what are the differences between them and where they can be useful. Until then, goodbye!